Now I am going to explain about quadrature phase shift keying. Phase shift keying is nothing but a digital modulation technique where message signal is represented by the change in the phase of the carrier signal. Quadrature phase shift keying differs from a binary phase shift keying where it sends only 2 bits of information at a time. Now let us look into the QPSK modulation and demodulation key. It has got mainly 4 parts or 4 blocks we can say. One is the message block, the second one is carrier block, sine wave carrier generation block, and the third one is bit splitter block, and the fourth one is this one, QPSK modulator part. So by using the first block, we are going to set the message signal. The sine wave carrier block generates 4 signals of different phases, 4 carrier signals of different phases. So these signals are given, these carriers are given to the multiplexer input ports, 4 different ports of multiplexer, and any one out of that will be selected to the output. So let us see the working of it. Initially, this port generates a sine wave of some phase, so that should be connected to the first pin of multiplexer. The second one generates a phase shift of a sinusoidal wave of phase shift 90 degree compared to the first one, so that is given to the second pin of multiplexer. So like that we need to do the connection. Next, the message bits what we have here, so it is in the parallel form, so that will be converted to the serial form here. The serially connected bits or message is connected to the bit splitter. The bit splitter actually splits those bits into even bits and the odd bits side. So these even and odd bits are connected to the select pins of the multiplexer in this way. So now, depending on the value what you get here, the multiplexer inputs will be selected. So if this value is 0 0, sine 0, so that means this signal will be connected to the output. If that value is 0 1, the value what you have here, if it is 0 1, sine 90, this signal will be connected to the output. If that value is 10, sine 270, so this one will be connected to the output. If that value is 11, this value is 11, so then sine 180 will be connected to the output. So let us see the output of that. Now I am taking the output with reference to the ground pin here. Now the message bits what we have here is grouped into 4 groups of 2 bits each. So now all the bits are 0 0, so we have sine 0 here. So that means the first signal that came into the output in all the groups. So now what I am doing here is I am making the first 2 bits, that is first group into 1 1. So the meaning is here the first bit 2 bits are 1 1 means, so here that corresponds to sine 180 degree. So that means the third signal here, that should go to the output. So that is what we can see here. Initially, so we have one signal here, so that is of 180 degree phase shift with others. So this shows the quadrature phase shift key. So now let us see the demodulation part. So in the demodulation part, the modulated signal should be given to the demodulator input, and we should take the output from the QPSK demodulator here. So now demodulation means actually we should get the original signal back. So initially the signal what we have given here is 1 1 and all other 0. So totally we have 8 bits. In that first 2 bits are 1 1 and all the other bits are zeros. So that is what we can see here. The first 2 bits are 1 1 and all the other bits are 0 here. So this total duration corresponds 1 frame, in that the first 2 bits are 1 1 and all the other bits are 0 0. So that is what that means we have demodulated the given original signal clearly. Thank you.